My name's Blackshaw and I'm the UK Product Manager for our Low Voltage Drives division here within ABB in the UK. This session is going to cover one of our probably most fundamental features within a lot of our drive products, in particular the ACH580 that I've got here, which is the PID control. Typical sort of applications you probably see this on are primarily sort of pump and fan systems where we want to monitor the temperature, if it's a fan for instance, or if we want to monitor the pressure, to name but a few of these things or units that we'll use at least anyway, where we want to give it a set point, so we need it to achieve this certain temperature or pressure, and then from there we either speed up or slow down depending on that application at least anyway. So in this example that we're going to run through using the primary settings, with the ACH580, we're actually going to set it up so that we've got like a hot water pump system, so that the water in the pump system is very cold. We're going to give it a set point, so then what will happen is that we speed up to heat that water up in the system, and then when we get to that set point, we are then going to you're going to see the drive and the motor slow down to sort of back off basically to a point where it could come to a standstill, or it just may creep very slowly depending on the behaviour of the system. So to set up this feature within the drive itself is quite fairly straightforward, and we start off on this main panel here on the control panel. So within the control panel, I've sort of predefined some settings on here already, which we can do that by editing the home view. But to actually initiate the PID, we go and select the menu button, and then we'll go down and we're looking for the primary settings, which is the second one off the list at least anyway. Within that, you'll see a whole host of different features within there, and what we're looking for is this PID control. We then select that, and there are two methods to doing this PID control within the primary settings. We can actually go sort of setting by setting how we activate it, where our start and stop and the direction comes from, what our units are, and things like the PID status and the feedback and set point. But we're going to do it in a much more simpler way, by going and utilising the PID assistant, which is basically a wizard, on how to do the PID setup. So by selecting it, using the select button, we then have a very sort of step-by-step process where the assistant will configure a very simple PID control using the secondary control location. So when we use this setup, it has a typical settings where our feedback is coming from our analog input 2, and the start and stop will come from our digital input 1. Once we're happy by reading through that, we click on to next. And then the first thing we do is we set up the analog input 2 scaling. So we have to set that accordingly, more importantly, because the temperature sensor we're using or the flow sensor we're using will have a designated sort of range that we have to adhere to, and we have to make sure that that's set correctly, otherwise we'll be interpreting that incorrectly. So what I've got here is my analog input 2 input range. So I've got that as a current input, so that's set to 4 to 20 milliamps, and because we're looking at temperatures, I've set my units to basically be degrees Celsius, but when we look through here, we've got a whole host of different units, but we can put our own custom text into there, so we can define what we want that to be. Oh, excuse me, knew I'd do that. But from once we've looked at the units, we've then got what the feedback is. So this is defining what our 4 milliamps would equate to in terms of temperature. So we're going to set that as 0 degrees Celsius, and in this case what our maximum would be, our feedback when analog input 2 is at its maximum. So this is when what the sort of maximum range of the temperature sensor is, which I've put as 50 degrees. Once we're happy with that, we can go on to the next, and then we now define what our set point source is going to be. So There's 3 different ways we can do this, and we can do it using a constant value. We can do it using the control panel, so we could set it using the up and down arrows on our control panel, or we set it using analog input 1. So I'm going to be a bit quirky. I'm going to go with analog input 1 on this, and once you're happy with that, we go on to next. And then we do now set the settings for our set point 1 scaling, because it could be, we're using a potentiometer to do this, and it's, we've got a potentiometer on the actual control panel itself. So again, we've got to set the input range. So I've got this set as 0 to 10 volts, but we can change that accordingly if we want to, and save that. And then we can do very similar with the analog input 2. We can set what our temperature range is going to be as well. So in this case, I've kept it the same just to keep it simple. So our analog input 1 at minimum, so at 0 volts, is 0 degrees Celsius. And our set point for analog input 1 at max is 50 degrees Celsius, just like the analog input 2. And once you're happy with that, we can click on to next. And then we have a menu that comes up with saying setup complete, which will take probably a couple of seconds to do. And it gives us sort of a checklist to say, this is what we've set it to, are you happy? And then we click on to done. And when it's done that, it will then save the parameters. It takes a couple of seconds, and then we've got our PID set up here now. So I'm going to click on the back button, take us all the way back to our main menu, and I'm going to give you an example here now. So in this example, I'm going to set our PID set points, our temperature, so that the pump needs to run faster to achieve a temperature of around about 21 degrees. Our feedback's going to be really low at the moment, so I'm just going to start to increase that gradually, so we can start to see a value at least anyway. And then once I get digital input to start, we can see now that the feedback's saying it's at 4 degrees. So we now need to, the motor's now speeding up saying I need to achieve that. So it's going to eventually gradually get to sort of its fastest speed point, which is 50 Hertz. And then once we get to 50 Hertz, I'll then start to imitate the feedback of the temperature increasing in this example at least anyway. Obviously in a real life system, this will alter accordingly. So as I start to now increase that temperature, now you can see this is very quick at the moment, but obviously in a real life system, it's going to be very slowly, but for the purpose of this, it's going to be a lot quicker. And you can see now the speed's starting to slow down, because we're at a point now where we've met our set point and we're over that. So we'd now start to slow down to cater for that. Now I could alter the temperature to come down, but I just want to quickly show you so that when it goes to a standstill, it actually stops. It's still modulating, and as we bring that temperature back down again, it will start to speed up for that at least anyway. One of the additional features behind this, which does show not on the wizard itself, but when you go through the list, is we have what we call a sleep mode. So what happens is that if we do get to that scenario where the motor comes to a standstill after a certain period of time, the driver itself will stop, so it's not modulating. So it's a good way it's a good form of saving energy, and it will effectively do what you tend to do when you go to sleep, is that it'll have some form of wake sequence. So it'll have some sort of trigger, so that if it does get too far to a low point or a high point, it will wake up and start to kickstart that again at least anyway. So there we have it, and that's how essentially the PID control works in essence at least anyway on our ABB drives range at least. So just want to say thank you for attending this session. If you haven't done so already, please feel free to catch up on any of our previous advanced HVAC control tips. Thank you.